Alright, so this one's going to be a little bit shorter. So what we're going to do is take the function f of x equals the square root of x. Its domain is 0 to infinity, and its range is 0 to infinity. So if you graph it on your calculator, you'll see the domain and range. Now what we're going to do is list some different functions that transform the square root function, and we tell how each how the transformations change the original f of x. So I can rewrite this. So I've written it as 2 minus the square root of x. I can say minus x plus 2. And so how is this going to change? It's going to go up 2. First it's going to flip over the x-axis. So actually, I'm going to flip it first and then move it up 2. So what happens? This is all vertical, so the domain stays the same. And what happens to the range is it goes up. It flips over the x-axis. So when that happens, the first change is it becomes negative infinity to 0. So that's just with the flip. And then we go up 2. So that's going to be for minus infinity, because infinity plus 2 is still infinity. So, but my range is minus infinity to 2. Okay, next one. G of x equals the square root of x minus 4 plus 3. So this says we move 4 to the right, and this says we move up 3. So the domain changes, move right, so 4 to infinity. So basically took the 0, infinity, and added 4 to get 4 to infinity. And the range is the same kind of thing. 0 to infinity plus 3 gives me 3 to infinity. And the third example, g of x equals minus 2x. Okay, so the minus flips it over the y-axis. And the 2 is a horizontal stretch. Whoops. And so I'm doing stuff along the x-axis, so my domain is going to change from 0 to infinity to minus infinity to 0. And then the minus 2, well, the minus does the flipping, and the 2 stretches it, but since it goes to infinity, I can't actually tell any difference. So, but the range stays the same, which is 0 to infinity. And so the main thing is to look at those. There's formulas. You'll have a handout that's got the different transformations, and so you just match up the transformation, what's showing on the graph, with what's in the table. Anyway, so our main goal is to tell, if we can tell how it changes the original, and we know what the original is, then we just find the new graph by counting what happens to through the transformations.